Hello and welcome to Devtoberfest week 3. This is the third Data and AI day of 4. Next week is already the last week of Devtoberfest, but it's not too late. You can still be part of the Devtoberfest contest. In order to take part in it, you just have to join the Devtoberfest group in the SAP community. I'm going to link the URL in the chat in a bit. And don't miss out, you have to take validation tutorials, listen to a lot of cool sessions. So don't forget to take the validation tutorial later today. But you can win a really cool prize. You can join us somewhere in the world for an SAP event. And the winners from last year, for example, are meeting us in Berlin this year. Yeah, all the news are in the Devtoberfest group, so make sure you join that in the SAP community. And today we have a really cool session from Tobias. He's from the SAP AI Core team and is going to tell us about something extremely new and exciting, the prompt optimizer. And with that, over to you, Tobias.
Yeah, thank you, Nova. Thanks for the introduction. Yes, I'm working in the AI Core team, and recently I've been working on this topic of prompt optimization. And today I want to give you an introduction into how you can manage and optimize prompts in SAP AI Core. And I will introduce the concepts to you and also show a demo and guide you through all the steps you need to take for performing an optimization. And let's first start with some motivation, which is that applications suffer from limited model agility. And with model agility here, I refer to the need of supporting multiple models. And this is needed because new models and new model versions are released regularly, and older model versions are deprecated. And applications need to change to those newer models. And also different models differ in terms of their availability. So for example, their regional availability, but also availability due to temporary outages. And then there are also the aspects of cost and quality, where different models have different advantages and disadvantages. And for all those reasons, you want to support different models and leverage all the benefits that different models have. And now you might ask, why is this a problem? Why can't we just support multiple models? And the issue here is that even though one prompt might be working well with some model, you can't just apply this prompt to another model because it might not be working well with some other model. So you need to adapt and test this prompt with every model that you want to use the prompt for. And this process currently is done manually. And this manual process of adapting and testing one single prompt for a specific model takes at least a full week if you do it precisely. So it can be very time and also costly. And this is obviously a big problem. And this is where our prompt optimizer comes in, because the goal of our prompt optimizer is to automate this whole process of adapting and testing prompts for a wide variety of models. And the way this works is that you can have some original prompt, and this is the prompt that you want to optimize. And then you can also provide a training data set and an evaluation metric, as well as a list of target models. And our prompt optimizer will then optimize your original prompt for every selected target model so that you end up with one optimized prompt for every model. And all this optimization is taken care of in an automated process. So you don't need this manual effort that was needed before, and you save a lot of time and also costs. And now I want to guide you through all the steps you need to take to perform such an optimization. So the process is the following. First, you create a data set. And this can be a JSON data set that contains a lot of training data. And you also need a base prompt. So in a second step, you also need to find the base prompt. And this is the prompt you want to optimize. And then you can, based on those two things, you can run the actual prompt optimization and execute the prompt optimizer in AI Core. And this will then trigger a whole optimization process, which can take a few minutes. And then in the end, you end up with one optimized prompt for every model, which you then can evaluate and also test, so that in the end, you can consume the optimized prompt from within your application. So you can use all our tools that you already know from AI Core and work with this prompt afterwards. So you can consume it using our APIs and our SDKs, or even within our UI AI Launchpad. So this is a very straightforward but very effective way to optimize your prompts. And yeah, to get a better understanding of this whole process, in the next step, I want to show you a demo and guide you through all those 5 steps so that you can see how you can actually perform such an optimization in practice. So let's start with the first point that we just saw, which is the data set. For today, I already created a data set in advance. And this data set contains of different fields. I want to show you this data set. So we have a number of entries. Sorry, I just heard the YouTube live stream in the background. Okay, let's continue with the data set. So we can see a number of entries here, and we have the fields and answers. And those fields, they are parameters that are part of our base prompt or the prompt that we want to optimize. So for example, we have the input parameter, and this is a parameter in the prompt that we want to optimize now. But in your use case, you could have also different parameters and even multiple ones. And then we also have a reference answer. And this is basically the correct answer to the prompt if you input this field that you see here. And we have a number of different entries as part of our data set, and all of those will be used for optimization. So in the next step, as I showed earlier, you can also define a base prompt. And to do that, you can also use AI Core and our UI AI Launchpad, which is available online. So you can use the Launchpad and its prompt management capabilities. And let's head to our prompt templates using this Launchpad. And here I also created a prompt template in advance, which I called base prompt. So you can see this prompt here. For your use case, you can also create your own prompts, but we will be working with this prompt now. And I want to guide you through this example. So this is a pretty straightforward base prompt that we want to optimize. So it consists of a system prompt and a user prompt. And the system prompt is only a rough description of what this prompt is about. And the user prompt explains the task of the prompt in more detail. So it explains that we want to extract and return some keys and values from a given input message. And the input message is the parameter that we just saw in our data set. So it will be filled in this prompt, and the task of our LLM is to extract some data. And this is basically the scenario that we are working with today, and the prompt we want to optimize. And to continue with the optimization, we can use this button over here, which says Optimize Prompt. And this will take us to a wizard, which helps us to perform the optimization. And now I want to guide you through all the steps you need to take and all the parameters you need to define. So let's start with the first parameter, which is defining the baseline run. And this parameter is already filled out because we used the guided tool and pressed this button on the top. But you can also select any other prompt that you want to optimize and that you've created in AI Core. Then the next thing is the origin model. This allows us to select a model that we don't want to optimize the prompt for, but that we only want to evaluate. So this could be some model that we are already using and that we want to use for some baseline comparison. But in our example, this is an optional parameter, so let's skip this for now. But you could be using this with your use case if this helps for your specific use case. The next parameter gets very interesting. So this is about the target models. So here we can select one or multiple target models, up to four total target models. And those are the models that we want to optimize our prompt for. And we can select from a wide variety of models that are available in AI Core. So you already know probably that we support a lot of different models in AI Core. So let's just select some model. Let's go with GPT-4o Mini for this example, but you can select any model that you like and even multiple ones. And we can select this, and with that, we are good to go and continue with the next parameter, which is the data set. And here we need to link the data set that I just showed you. So this JSON data set with the training data. And I already uploaded this exact same file earlier, and we can just select it using this wizard. And it's called input data in my case. So let's select it and also specify the exact file name within that data set so that we can find our optimization data set. Those are the basic configurations we need to take. The next thing is selecting a metric. And here we have two different options. This metric will be used for the optimization, and depending on our use case, it makes sense to use one or another metric. The first metric is called semantic similarity, and it uses an LLM as a judge model to evaluate how similar the response of the model is with the reference answer in our data set. So this can be applied to scenarios where the answers of the LLM don't follow a strict pattern or format. So this can be very useful for some use cases. The second metric is a JSON match metric. And this is specifically used for use cases where the response is in a JSON format. So for example, in our use case, you saw in the prompt that our use case is about extracting some data in a JSON format. So this second metric makes a lot of sense in our scenario now. So let's go with this second metric for today. And then we also can specify some additional parameters. So for example, we can specify the target output mapping, where we can define some names for the generated prompts that are the output of our prompt optimization. But we can also use this auto-generate button over here, which will fill out those fields with some default values. But feel free to use names that suit your use case best. So let's go with the predefined values for now. And then last but not least, we have some advanced settings. For example, we can enable few-shot prompting, and this would allow our optimizer engine to inject data from the training data set into the optimization flow. So this is also an optional parameter. We will leave it disabled for today, but you can play around with this configuration and see if this gives even better results for your specific use case. And in case you're wondering about any of those parameters, you can often find some hints in our UI, which will give you more details on all the parameters that you can take to make the whole optimization process even easier. Let's review all our configurations, and we can see that all the inputs we took are as we intended. So let's confirm and create our prompt optimization. And this now in the background starts our actual optimization job. So this will now iteratively improve the prompt that we provided as a base prompt and make sure that we end up with improved results. With this configuration, I expect this job to take about 5 to 10 minutes, but the runtime is totally dependent on the models you choose and also the data set that you provide and the prompt you want to optimize. So that we don't have to wait for this job to finish now, I already started a job this morning. So let's have a look at the finished job and at the results that we got from this job. And to head to those results, we can use this optimization button on the left. Here, we can see all the previous runs. And let's have a look at this one, for example. And here we can see the exact results of this job. And this was a job where I actually used multiple target models and optimized for different models. And we can see that for different models, we had a different performance. So for example, for GPT-4o Mini, the baseline score, so the score that we had without an optimization, was already pretty good. So it was 86.7. And with our optimization, it was improved slightly to 87. But for example, with GPT-4o, we can see that before the optimization, the results weren't so good. They were 82.9% of accuracy, and they were improved to a score of 89.3. So even though GPT-4o was pretty bad in the beginning, after our optimization, we were able to achieve results which all the other models weren't able to match. So this could be a good option that we could take for our application, and we could use this optimized prompt of GPT-4o for our use case because it performed very well. So let's say we decide on this exact same prompt and model, and we want to see the prompt. To do that, we can head to the prompt template that was generated as part of the optimization. It is linked here, so we can click this link, and this will again take us to the prompt management page of AI Launchpad, and we can see the optimized prompt. And if you maybe remember the base prompt, you can already see that the system prompt got adapted. It got a bit more detailed, and also the user prompt was adapted according to our use case. So you can see it also got more detailed and was adapted so that we can yield better results with our prompt and our model. And this is basically the whole flow you need to do to optimize your prompt for given models. So it's very straightforward. And from here, you can continue your workflow however you like. So you could use this prompt using our APIs or our SDKs, or you could even consume it from right within AI Launchpad. So for example, you could open it in a prompt editor using this button, and this will allow you to send this prompt to some model that you want to use right away just from within this UI. You could also fill out the input parameter that is part of our prompt to consume this prompt. So there are a lot of options you have that you can continue working with this prompt now. And that's basically the whole process end to end from creating a prompt and optimizing this prompt using the new prompt optimizer. And with that, I thank you very much. And yeah, we'll have some time for questions, and I will answer all your questions. And with that, I want to hand back over to Nora.
Thank you. Hi. If you have questions, post them in the chat. Otherwise, I start with my questions. I always do that. I'm selfish like that. So go ahead and ask any questions that you might have. And until I see any in the chat, I'm just going to ask you what I have. Oh, there's one. So AI Launchpad is graphical way to look at all AI assets, right? You can answer that, or I can even answer that now. Can you go ahead?
I can go ahead. So AI Launchpad is a UI that is basically the UI of AI Core. And AI Core allows you to do a lot of things in the field of AI. And you could, for example, use AI Launchpad to consume LLMs, but also to manage your prompts like I just showed you. So you can create your prompts, you can send those prompts to models. You could even deploy your own AI executions and deployments. So you can even train your own models and stuff like that. So we have a lot of features that we offer with AI Core, and AI Launchpad is basically your entry point to consume all that functionality.
Yeah, that's what a lot of people don't really know, right? That AI Core was around before there was ChatGPT, and you can train your own models and do stuff with it.
Yes,
people are always surprised when I say that.
Yeah, we have a lot of features, yeah.
What is the use of AI Core? That's the next question.
Yes, so AI Core, as I said, is basically a platform, and we offer a lot of different functionality. So you can use all those AI and LLM functionality, but you can also train your own models and deploy those models. So all that I just have shown are some use cases of AI Core, but there's even a lot more functionality around AI that you can consume. Feel free to check out our documentation if you have some specific things that you want to know. But yeah, it's a great tool that you can use for all your AI workloads.
Yeah, AI Core is basically our AI runtime where you can, as Tobias already said, train your own models, deploy models, also not like large language models. It can also be any other machine learning models. So don't quote me on this, but basically anything you can put in a Docker container, you can do in AI Core. And then with Generative AI Hub, we just added a layer on top to proxy for all the large language models that we partner with. I mean, some of them we are hosting ourselves, but most of them we just proxy for. Like, I don't know, GPT-5 and all the Bedrock models from Amazon and the Gemini family from Google, and other OpenAI models, obviously. Yeah. Or can I also use classical AI models? Yes, exactly. That's what I just said. And what Tobias also said, you can also deploy classical AI models, also statistical models, like any small machine learning models. You can deploy there as well. How do you see the best scenario to use this prompt optimizer?
Yes, so you can apply this prompt optimizer to a lot of different use cases or scenarios. So usually the way it works is that you have your own use case that you want to work with. So let's say you have some application that wants to use some large language model, and you could take exactly this use case and use some prompt that you might already be using or that you are creating for this application. And you can use this as a starting point to optimize a prompt for this exact scenario or for this prompt. So basically, this applies to all the prompts that you are using. So it's not about selecting some scenario. It's basically about using the stuff that you want to optimize and the stuff that you want to use.
So one question of me that fits here, I think, in the semantic similarity option, and not the JSON matching option, when you choose your LLM as a judge, do you need to have like a ground truth already to what the prompt is going to put out, or is the judge just judging what is a good prompt in the scenario and what is not?
Yes. So there are different approaches to this topic of LLM jobs. And the metric that I just showed, so we currently have those two metrics. We have this LLM as a judge metric and the JSON metric. And you are talking about the first one, the LLM as a judge metric. And this works with a ground truth. So this ground truth is part of our data set. But there are also other approaches where you don't need a ground truth, but fully give the responsibility of judging to the LLM. And as I said, we are planning on bringing more metrics. So metrics that don't require a ground truth are also an option for those future metrics. So there are different approaches to this topic of LLM jobs.
Okay, cool. Thanks. There was one more question. AI Launchpad is no use if you don't use AI Core in that case. Exactly. AI Launchpad without AI Core. You need to add a system. You could actually in the past also add AI services as the AI runtime, like data attribute recommendation and stuff, but yeah, stay tuned for TechEd to figure out how that works in the future. Are there any other questions? Otherwise, I still have some. Okay, I'll give them some time to come up with more questions. Yeah, one question I had, which I think you didn't show, was where do you upload the data set? And this is probably also fitting to this what is AI core question, because in AI core you can upload data sets originally to train your own model, right? But right now, are you using the same dataset artifact for your use case, or is there another place?
Yes. So we built on top of already existing AI Core functionality here. So you can upload your data set to some object store. And the way it works with AI Core is that you register this object store as an artifact. And this is where we fetch the data from. So this is similar to other parts of AI Core where we already use this concept.
Nice. Oh yeah, how is this optimizing actually working? I was wondering, like, so is it just trying out different prompts and running it and seeing what the output is and then comparing that to the output that you want, or how does it work?
Yes. So it's basically an iterative approach where we use LLMs to optimize the prompts. So we have LLMs generating new prompts and also evaluating those prompts. So it's basically an iterative approach of generating new prompts and checking whether those new prompts are better than what we already have. And by that, we end up with prompts that are better than what we had before. So it's basically, one after another, we improve step by step. And that's the overall concept.
And when it's testing that, so this iterative process, you do have some sort of input that you had as a parameter, right? That was empty. And then when someone is running the prompt, this input is being pulled from somewhere. What does that input look like in your case, for example?
Yes, we can have a look at the data set that we used in our example just now. So you can see we have a number of entries here. So each of those is one example of an input. So here we have an input with some text, and then we have the golden output, the answer. And we have multiple examples in this file. So each of those is one example that is used for the optimization.
Yeah, okay, now I get it. Interesting. Hold on. I had one more. Let me check. Instead of Docker, can we use pods for here? That I don't know. You would have to answer that.
I'm not sure about this question. So in the background, we are working with working with Docker and Kubernetes. So pods are part of Kubernetes. But so we are providing all this functionality as a service. So you don't need to work with any pods or Docker. So this is fully managed by us. So it is very easy for you to optimize the comms even without working with the infrastructure below. So yeah.
Cool. Okay. Are there any other questions? Because I have mine all answered. I understood it now. I don't think so. Then I'm just going to thank you, Tobias. It was a really cool session. I actually really understood what it's all about, which is awesome because usually in my daily work, I have to figure these things out on my own when there's a new feature. So I thank you very much for saving me from this. And yeah, if there are any more questions, you can always ask them in the comments, and Tobias is going to answer them once I tell him there's a new question. And otherwise, I see you all hopefully in half an hour again. So thank you so much, and see you soon. Bye.
Thanks, everyone. Bye.
Okay.